Okay, good morning. Yesterday we finished with the well-architected framework. I believe we started on Monday, and yesterday we were able to finish with it and then go on to look at another topic. So before we look at what we have to do for today, let's have a short recap. Does anybody want to tell us what they remember from Monday or even yesterday's session? Hi, Calvin.
Good morning, Kusha. Good morning, everybody.
Mm,
So yesterday we looked at the difference between reliability and high availability. We said reliability is a measure of how well a system can perform its intended function over a period of time without failing or malfunctioning. And availability is system accessibility, which qualifies the amount of time a resource a resource is available for use without interruptions or downtime. Thank you.
all right, thank you, Calvin.
Welcome.
So yesterday we looked at reliability and availability, and under that we said that reliability refers to how long a resource performs the function that we intend for it to perform, and availability has to do with the percentage of time that a resource is operating normally. And under availability, we saw that when it comes to AWS services or even our applications, we would see that we would have some nines of durability. So who can tell me what 4 nines means? Sorry, nines of availability. So if I tell you a service has 4 nines of availability, what does that mean? Or what is the actual figure over 100? Dennis.
So over 100, it will be 99.9999.
Um, who else can try?
99.99, two nines after the point.
Exactly, because there are 4 nines in that figure. Okay, so if it's 5 nines, we know it's 99.999. So this is some like a measure of availability that you would see when you use some services. And it's measured per year. So in a year, the number of or the percentage of the year. So we have 365 days in a year. So the percentage that's the service provider is allowed downtime, the percentage that yes, they're allowed downtime. And we also saw that ideally services are restored, especially from AWS side, in less than 1 minute. And I mentioned that we should all strive to make sure that people say things like that about our application or about about our application. People should say that I've been using this service, I've been using this app for all of these years, and I've never seen them go down before because we keep the availability of our service that's high. Okay. Perez,
Yeah, hello, Agosha, good morning.
good morning.
On a Monday, we looked at the cloud, the cloud adoption framework, and then we said that they were guidelines that help us develop an efficient and effective plans throughout our cloud journey. And then also I remember we also saw some core perspective of the cloud adoption framework, which is business people and business capabilities, and then the governance focus. Thank you.
All right, thank you, Perez. So yeah, on Monday we looked at the cloud adoption framework, and we said that when organizations are adopting the cloud, this is a plan. So the framework kind of helps them to draw a plan so that they look at the necessary aspects in their organization that they need to take care of before they would successfully be able to migrate to the cloud. Can anybody help us with some of the perspectives that we remember? I think Perez mentioned business, people, governance, the technical, the other three. Who can help?
Yeah,
I think
platform
we have
security and
operations.
operation.
Exactly. Thank you, Ruben. So you need to make sure that these domains, how you operate traditionally or pre-cloud, when you finally move to the cloud, you'll still be able to continue with these operations seamlessly. If moving to a cloud is going to pose a problem, or there are some gaps that you identify that could hinder or that could cause problems when you move to the cloud, then the cloud adoption framework would, because you're going to be defining your present operations, it would help you to fish out all those gaps so that you'll be able to put training, financing, and those things in place before you make the move to the cloud. And still under cloud adoption framework, I also mentioned that while you are using this framework or this plan, there are some 4 phases that each company goes through before they finally adopt the cloud. Does anybody remember those 4 phases?
Yes. Can I say?
No, I think somebody else should say the 4 phases.
Let me say only one.
Okay.
Envision.
Okay, so envision the plan where you see your how you see your company benefiting from the cloud. Okay, so envision is like the plan. So what is the second phase, William?
Align.
Align. So align would be where you have the plan and then you go on to use that as a guide to make some changes inside of your organization. And the third stage, Terry. Oh, that's not why your hand is up.
Oh, that's not a reason, please.
Okay, then it's the third stage.
Launch.
Exactly. So with launch, you would have a pilot phase where you would adopt the cloud, but you would do it in a minimal state, okay? Just so you are able to demonstrate, you're able to show working for that business value that your plan is saying you're going to get. And the final stage, William.
Scale.
Thank you, William. So yeah, scale is the final stage. So after you launch or you carry out your pilots and then you know that the cloud is good for you, then you scale to the full production value or the full production numbers that you want to have on the cloud. So these 4 phases are these 4 phases of the cloud adoption framework are what each organization ideally goes through before they finally adopt the cloud. And what's it called? So yesterday I timed the test because I didn't want you guys Googling and checking GPT. I wanted the raw understanding from what we had treated in class. So I wanted to know who was listening. But there are some problem solvers that if you give it a challenge, they would still find a way around it. So I noticed that some of us were putting some answers, but then they ran through. So that's how I know that it's probably from Google or GPT, because I have never mentioned those things in this class before, but a number of people had those same answers. Terry.
All right, so we also learned about the 6 pillars of the AWS Well Architected Framework. So I want to talk about just three of them, and then I will leave the rest to my colleagues.
All
So
right.
the first one is operational excellence, which includes ability to support development and then run workloads efficiently. It also helps to gain insight into operations and then continuously improve support processes. The next one is the security, which includes ability to protect data, systems, and assets to take advantage of cloud technologies. It also helps to improve security as well. The next one is the reliability, which encompasses the ability of workload to perform its intended function correctly and then also consistently when it's expected to. So these are the three that I want to talk about.
All right. Thank you, Terry. We looked at a well-architected framework and we saw some of the pillars: operational excellence, security, reliability, sustainability, performance, efficiency, and operational excellence, security, reliability. Guys, please can you remind me about the other two?
Cost
Cost
optimization,
optimization and
sustainability.
sustainability. Yeah. Thank you, Ruben.
Welcome.
So under each of them, we looked at what the pillar is about, which you'd find in your one of two documents. And then we went on to look at the design principles of the pillar. So if you understand the design principles under the pillar, that would kind of be a prompt for you to know what's to know which of the pillars that's design principle is referring to. So with the help of you guys, we're able to go through the various pillars, and then we're also able to what's it called? We're also able to look at the design principles under each of the pillars. But one understanding that wasn't really clear was the difference between performance, efficiency, and operational excellence. Yeah. So even before we had the group that took performance efficiency yesterday, we had already started having conversation about how these two, because they have an overlap, they could be confusing sometimes. So I explained to the best of my knowledge, Ima explained to the best of his knowledge, but it looked like there was still some yeah, so the understanding was still not there, because I noticed that for with the test, those two topics, so yes, those two pillars, the answers under both were still confusing for some people. So I think just to put it as simply as possible, we can say performance efficiency would be about the efficient use of resources. Okay, so using the right tool for the right job. You know you are going to be expecting what's it called? A lot of traffic. Okay. A lot of traffic means that your CPU utilization is going to go higher. So you need to provision an instance that would be able to bear that load. Okay, so you get the appropriate tool for the job that the tool is going to do. And one of the, what's it called? The design principles under performance efficiency was mechanical sympathy. And the way I explained that was that if you should provision a T2 micro, which is an instance that is not so performance, the specifications are not so great, okay, and you know you're expecting traffic from a lot of people, you haven't been sympathetic with your use, because your instance is going to suffer. Okay, your instance is going to be overloaded, overwhelmed. It's not going to be of optimal performance. Now, with the other side of things, operational excellence is focused on how you maintain and you improve upon the operational processes that go on when it comes to provisioning your infrastructure. And one of the design principles under operational excellence is perform operations as code, which I explained that you should have ideally, so this point and click that we have been doing, ideally you should have or it will be a better option for you to have a cloud formation template that does this for you. And another design principle to under that is making changes in small making small frequent reversible changes. I think yesterday that's question came about twice. Making small reversible changes means that if you should test out, so ideally you should test out whatever change that you want to make to your operations. And when you do, don't implement a huge change that is going to could end up breaking down your system or something of that sort. So you should always have measures in place where you can roll back if that small change that you made is causing any issues. Okay, so it will be easier to reverse, or it will be easier to manage a small change if something goes wrong than if you make like a huge change. Okay, so the operations and then the way that you are able to deliver business value as much as possible, you should automate them. You should when making changes, you should do them in little increments. Okay, so small change by small change. And you should also prepare for when incidents come your way. So your operations, the way that you go about provisioning your infrastructure, you should have a plan in place. Okay, that's if an incident should happen, you should be able to you have code that is going to help you to recover. Okay, so so reliability might be coming in here, so I'm just keeping it at a way that we do not confuse you. But if the infrastructure that you provisioned, right, you did point and click to get that infrastructure, and right now something has happened to that infrastructure, you would now have to go and do point and click again, right? So the idea that I'm driving at is that if you have a code, you would just be able to go and run that code and get your infrastructure back again. Okay, I don't know if the difference is clear to us now.
Yes.
Okay.
Yeah, you mean you do mean code to be in automation form, so that in case of any hint through the code that has been made as a automation or signal, like simulator, for you to know what is about to happen, so that you get prepared of.
Yeah.
So concerning the code aspects.
Yeah.
So if
you're welcome, Ruben. So for example, if you anticipate failure, you think that, okay, this instance could go down. When it goes down, how do I reduce the time that is going to take for the instance to recover? So you should test your failure scenarios and validate your understanding of their impact. And you should also test your response procedures. If anything should go down right now, how are you going to respond, so that your team would be familiar with the launch? So if an instance should go down right now, we know that we have our auto-scaling group that will take care of it, because when we were provisioning those resources, we looked into all of those things. The pillars all kind of relate to each other. Okay, so I just hope we have that understanding between both of them: performance efficiency, using the right tool for the right job; operational excellence, the processes and operations that go on for you to have a reliable what's it called, system, okay, for you to be able to provision whatever resources, or for you to be able to make your service available to the end user. That's would like mean your operations. I think those are the things that we treated yesterday. Yeah, these are the three things: highly available, what architect said. Yeah. So today we've been speaking about how we can use the cloud adoption framework to help a company to plan their cloud move. And we've mentioned those stages or the phases that each company would go through when they are moving to the cloud. So we are going to look at a case study kind of when a company is actually moving to the cloud. So all these planning that we've been doing, now is the time for the company to move to the cloud. And we are going to look at how that's done. So transitioning a data center into the cloud. We're looking at an example of how to transition a data center to the cloud. We would learn about the components and characteristics of this example data center, and we would also look at how an example environment could be set up and run on AWS instead. Okay. So this is the corporate data center. So one application we've been using in this class is Jennifer's lecture recording app. So I think I can continue to use that as an example as we go along. So this is how traditionally the data center looks like. Okay, they have they have this setup, and these are two servers that are their okay, who can tell us what's it called? The cloud, no, was it cloud equivalent? So when we're looking at the two ways to interact with a database, who can remind us about the two examples that we saw? Okay, I'll mention one, and then I'm sure then somebody will know the other one. So the first one.
Is it a star?
No, the way we interact with the database, how you can
Of course, the
configure.
client server, then the create here.
Thank you.
Okay, the client server and then the network base or something like this.
Yes, please. The client server and then the 3-tier. So with the client server, your application or your web app has direct integration or has a direct connection to your back end. So if somebody who is using your app should tap on probably search, so they type something, then they tap on search, what would be happening is an SQL command would be run in your back end inside of your database, and then it will retrieve that information for that client. Now, the second setup we saw was a 3-tier application, and inside of the 3-tier application, we saw various layers. Can anybody remember those layers that we saw? Odum.
We have the presentation layer, the application layer, and the database layer.
All right, thank you for that, Odum. So when we were choosing that, we hadn't even yet gotten to RDS, okay? We're looking at how typically a database would be interacted with when it comes to our app or when it comes to our architecture. So we can see from Jennifer's lecture recording company here that they also indeed do have a 3-tier application. So this would be their web server, which is their presentation layer. So if you are accessing Jennifer's app today, that page that will tell you, welcome to Jennifer's app, sign up here, sign in here, all those design stuff, that's the presentation layer. Then we move to the app server. That is likely her application layer. And what this application layer is doing is that it's providing some function. So in this case, what is the function that is providing? What are we going to Jennifer's app to go and do? Jennifer. Is she here today? Okay, she's not here today. But you guys do remember that she mentioned that she wished she could have an app that records her lectures in the first week.
Yeah, I remember she said something like that. Yeah.
Okay.
Nah, I don't remember.
William, you don't remember?
No.
Okay, so I had you guys give me app ideas. I think Odum spoke about an expense tracker and those things. But do you remember that session, William?
I think so.
Yeah, it was in the
Akosia, have
first
you
week
been, have
of
you,
Canvas.
Akosia,
Yes, David.
have you been writing these things down?
No, the ones I remember are the ones I'm mentioning, but there were a lot more. There were a lot more that day.
Seriously.
So I feel like if you are able to remember things that happen, you'll be able to remember what relates to them. I don't know if because so this course is quite stressful, it's quite a lot, and it will be difficult to remember everything. So those little things that help you remember those official things. I don't know if you get what I mean. You should embrace them.
Because honestly, I don't remember. So anytime you mention Jennifer's app, I'm like, how to
Did
benefit
Jennifer do an app?
Wow. Then I think we need her here herself for her to come and say what she said on that day. Okay, so let me just mention what I remember about the app again. She said she wished she had an app that could record her lecture notes. And when we were treating the software development lifecycle, I used that as an example again that now that Jennifer has told us what she wants her app to do, we need to have a plan to prevent scope creep, because one day she could come and go like, okay, now I need the recorded sessions to be explained to me or to be translated in another language. So we should always have a plan if we are going to develop any software. So that's when I used her example to explain the software development lifecycle. But you guys remember the SDLC?
Yes.
Okay. So people visit her app to go and record their lecture notes, okay? Sorry, to go and record their lectures. So that's the function that her app is providing for us. So inside of that application server, the service or the function or an application that we are likely to find on this app service would be a recording app, okay? Now, another application that we are likely to find would be something that's probably takes care of authenticating and authorizing people who want to use her app, okay? So inside of her primary database, the information that will typically be stored there would be people's logins. So when you visit her presentation layer and you are trying to sign in, you provide your username, you provide your your password, and a hash function is generated when you provide that password. And inside of the app server, that's your password that Jennifer has already assigned to you, or that's the database knows about you the day you were registering. That hash function is compared to the hash function of the one that was assigned to you when you registered. If it's the same, then you are allowed to sign in. And probably some other information that Jennifer would keep in the database would be information about some recordings that you've already made to that exist in your account. So it would have information about those recordings, but recordings are not stored inside of the database. They would be stored in the network attached storage server. And then they also have like a file system database too. Yeah, so that's what this setup does. Each layer has something that it stores or some function that it serves. And with Microsoft's Active Directory, this is used in a lot inside of the traditional setting. So it has, so for example, at Amalitech, everybody who works here is registered to a domain. It's called a domain. And each computer, each person has say like an account. Okay, so we can think of it as a people management system. And then the main thing that it does is that it manages access to Amalitech's network. So it's a centralized platform for user authentication, authorization, and it also takes care of access control to network resources. The network resources could include printers, file shares. So when we talk about file shares, please bear in mind that this thing we are looking at is more internal, okay, because we're looking at a corporate data center. So this is a traditional setting. So when we talk about file shares, probably everybody in HR, they should be able to have access to some HR related information. That information or those documents would be stored in a file share, an HR file share. So when you authenticate any user or any employee, those people would only be able to access. So if they're in the HR department, they would only be able to access that HR file share. If it's top management to also have their own file share where they have documents and files that only them are able to access. You have some printers inside of the traditional or inside of your company, but it's not everybody that has access to all those printers. So probably the CEO, those people have access to a particular printer. Then you, the employees or even the NSPs, they also have access to another. So we can think of the Active Directory, Microsoft Active Directory, as an app that helps us to manage these users and their access to network resources. So you being able to, the computers you can use, the laptops, etc., just a centralized place to manage all of those things. If your computer can connect to a printer or this network or not, those things. So we can just look at this as central management and access control in the traditional setting. Okay. So this is block level storage, and it's here, it is attached to these 3 app servers. So if anything is going on in these app servers and it needs some storage, it needs somewhere to be storing what is on it, it can use this one. And if it is some information that is storing to be shared, then it would use this one.
Hi, Akosia, please, could you come again?
If the app needs to store some information, for example, the recordings, it could store them on this storage area network, because it is for this traditional setting. So it has been configured to be the storage of these app servers. Is that okay?
Yes, please.
Okay, so we would move to the, what's it called? The AWS version of things soon. So I'm trying not to bring okay, let me just mention them anyway. So yesterday, Ima helped us understand the difference between block storage and file storage. This file system database would usually keep information that multiple servers need to access. It's a file storage and is network bound. While the block storage, it can be thought of more like a hard disk. So when we get to the AWS side of things, I think it would be clearer. Yakubu.
Morning.
Morning.
Say the first, where the corporate data center is, the first server, that is, yes. So that is the presentation layer. Okay. That's where the app is, right? Like I'm trying to find a difference between the web server and the app server. Yes.
Okay. So the app server has the recorder in this example, or let's say we are using a calculating app. So the calculator will be here. And then the web server would have the web page or the user's access into the web app. This is where, like here, the GUI, the user interface that your users would interact with. That's the web server.
So, like the front end, right? The front end.
Exactly. Yes, the front end.
So is that different from the app?
Well, they are integrated. So when you're working here, you can be able to retrieve or get functionality from here and here. But this is where the clients, they are, I don't want to say where they stop at, but this is where the client comes to meet, and through the user interface that you've given them, they would be able to do this and do this. So let's look at this, for example, this page is their web server that's serving us this page. All these things that we can look at, billing, whatever. But anything we need to do, if it would need to get information from the database, or it will need to get some function from the app server, we can get it done from here because you and I are users of this AWS app. So we'll get it done from here, and then the app server would retrieve or perform whatever function it is and come and show to us at the presentation layer.
Okay. Okay, so if I understand what you're saying, like when we are on our laptops or on the phone, we are at the web server, but then whatever we do, it happens in the app server.
Yes, and some setups, they combine this web server with app server, but you need to bear in mind that means that your CPU utilization is going to go up. So that means whatever server that it is that you are combining these two functions on, that server is going to have to be highly performant. You should provision specifications that would fit because they would kind of be doing a two-man job now. Yeah, so when you decouple them like that, like this, so when you separate them like this, it's best. But sometimes to save on cost and those things, we would have people, especially when you don't have a lot of traffic coming to your application, you would combine this one and then this one. So in that example, that server that is combining both functionalities, we'll find that Nginx, Apache, HTTPD on it, doing web server job. And we would also find a recording app or a recording software doing that recording job on the same server.
Yeah, okay. Okay, all right. And then my second question is, so a database stores data. So why would we also need a storage? like I know about the redundancy but then we can also have multiple databases for redundancy or for availability.
Okay, so databases, the kind of data that databases store is typically small, what's it called? So text, okay, text and then smaller sizes of data. Okay, but those large data files, like so in this case, they would need somewhere to be storing their recorded audios or videos or something. It's better to store them on your hard disk than a database. So if anything would be stored on the database, it would be that information about the one that they have on the drive. I don't know if, okay, let me give a typical example. So let's say you, Yakubu, you go to record a session. That session would be stored on this storage area network, and information about that your stored session would be stored in this database. So let's say RDS. So inside of RDS, there's a table that has your name, your email. Then there's another table that has your email, assuming you're using your email as your primary key. And then another column that that table has is the, what's it called? The root, sorry, the absolute path to your recording. The absolute path to your recording would be inside the database. So the program would be coded or developed in a way that when you request for that your video, for that your audio recording, it would look at the database will provide it the absolute path, and it would be able to go into your hard disk and fish out the recording that it is and present it to you. So we have both this hard disk or this storage, and we also have database, because for some applications, it's not just data that they are storing. So it's not just text, information that they are storing. They might need to store recordings, videos, pictures. You could use S3, and you could also just use your your EBS or your hard disk or your file system. Okay, so it's not everything that we can store in the database. The database has things that it stores, and then your hard disk still has things that it will store. So depending on what people are accessing or what your app does, you would need both. And even the recording app that you have, or the calculator app that you have, it will need some storage. Even the Nginx will need some storage, and you can't store that in a database. So you store that on your hard disk. I hope you're understanding.
Yes.
Okay. I think somebody else's hand came up after Yakubu asked this question. So that you had the same question, or you wanted to help with the answer.
It was me. I wanted to help with the answer.
Okay,
But I think your description is fine.
Okay, but I think you could just say what you wanted to say too.
Yes, I was going to say the same thing, that the database typically stores information about files. So, for example, so there are things called entities, right? So every entity has properties. For example, if we're talking about the lecture recording app, right? So every lecture would be an entity, and every lecture would have properties like maybe a start time, an ending time, a lecturer, maybe a list of students and things like that. And then it would also have maybe stuff like the name of the recording file. For example, they can use the date of the lecture and the time of the lecture to help to make the file name itself unique. So then the file name itself is what to be stored in the database, and it's be related to maybe to this morning's lecture as maybe lecture 1. So then lecture 1 actual recording file, which is the video file, is what to be stored on the storage server. which I think is what you
All right, thank you. And yeah, so before you provision your database, you look at the kind of information that you're going to you need to store about your app. And that is how you're going to structure your database. So your database should be collecting this information about users, this information about the recordings, or this information about the calculations that are going on. Okay, then that is how you design your app, have your various tables, and then you would integrate that. So your developers would make all of that come put all those factors in place so that they can seemingly work together to have the app running smoothly. Dennis.
Yeah, please, I had a question. My network was messing up at some point, but I don't know if you have said it already. So, my question is that there's the storage area network where you said like the server will store some data that cannot be stored in the database, and I understood that. But then, from my understanding, I know storages come with their own file system, their protocols like embedded. So why the need for another file system database like on the right side? I don't really get that side.
Okay, so the example I gave was about the metadata or additional information about the recording. But apart from that, there's more information that a database stores, something like sign-in information. Sign-in information would typically be stored on the database. I don't know if I've answered your question.
Yeah. But the file system database.
Oh, okay. The file system database.
Yeah. The one between the network attached storage and the app service. I mean, yeah, the network attached storage between that and the app server.
This file system database.
Yes, yes. I want to know what the functionality.
Okay.
Hello, Akosia.
Yes, ma.
Please, could it be that, this network attached storage, it's more or less similar to the storage area network, only that one deals with files, like a file storage. So could it be that this database is what is going to, just similar to, the other database, you are storing your data in this, and then any large files, which we don't have to store in the database, that will be in the network attached storage. And then the database will be pointing to it. So that's what I'm thinking, that probably this file system database is a database for the file storage.
Okay, that makes sense.
I still don't understand. Because at the end of breaking down everything, I think everything ends up in a file anyway. So I don't really get what you mean by file. It stores files. Because even let's say the
I'm
recording.
trying to get example to show you.
Yeah, okay.
Once I come up with, I'll share with the class.
Okay, so the way the primary database focuses on relational data, the file system database would focus on more than just the text or relational data. It would also, so the absolute path that I spoke about, it would be stored in a file system database rather than just the primary database. So you have both of these databases, and depending on what you need to store, it could go here or go here. So this one would take typically the what's it called? The text. the data that I spoke about, like sign-in information, and then this one would keep something more, so something related to files, or yes, so file data would be on this file system database. Is that okay?
Okay, and then what will be on the storage area network?
The storage area network will have your recording app. The storage area network is like your hard disk, okay? So your recording app, your what's it called? Your Nginx, all those things, they would be on your storage area network.
Okay.
Your server is going to need storage, definitely. It's like your
Yeah.
computer without your hard disk.
Okay. So that means the storage area network is inside a server. Let's say if we are looking at a physical server, it will be inside the server, or it's separate from the server.
I think from the diagram, it looks separate from the server. Oh,
Yeah, and then
Hello?
because it's operating with the network too, so it could be separate and still be able to perform its function. So I think it is. Or it could also be that it's inside, or yes, it is inside of the server, but just for demonstration purposes, they just brought it here. Because typically your hard disk is inside your computer. Okay.
Yeah.
Yeah. So I think it's inside, but for demonstration purposes, they did it like this. But it's not that it's somewhere else.
All right.
Yeah.
Thank
You're welcome.
Hello, Akosia.
Hi, John. So, John, I believe you worked in a traditional data center before, right?
Yes, please.
Okay.
Um, usually, in a very, let's say, serious environment, a big data center, you have your SAN, that's the storage area network, sitting separate from the servers themselves.
Okay.
Yes, they're sitting separate. If it is a small thing that you are doing, then you can incorporate it into the server as well. But where you have, let's say, 12 hard disks sitting inside your SAN, they are separate, and then you are using a fiber channel connector, storage area network. So that is what we have done before.
All right. Thank you for that insight, John.
But
Dennis,
then,
please,
so
are you
does it mean
okay?
that so does it mean that, like, in this sense, the storage that comes with the server is not enough for the data? That's why you need to set up the SAN. Because I mean, from the definition of a server from the beginning of the class, we know they come with high specs, so high storage, high memory, high processing power. So do you need a SAN when the storage inside the server is not enough for what you want to do? Or I don't know, or it's necessary
Okay.
that in every setup?
John, could you please help us with that? Yes. So when you want high speed, low latency, and high volume okay.
Please, can the question be
Dennis is asking if you need a SAN because the storage on your application or on your server isn't enough. Is that why you would need a SAN?
Hello, Akusa, please, can I say something?
Okay, go ahead, Enam.
Okay, so usually in
no, not
data
exactly
center.
so. Akosia, can you hear me?
Yeah, we can hear you.
Hello. Okay. So as I was saying earlier on,
I mean, you would be implementing, let's say, some kind of a rating system, RAID. You will need to write your data as they come in, as people are using your application server across some form of a RAID. And you would want to have a whole storage area network. So, hello, can you hear me?
Hi, John. We can hear you. So what you're saying is that
Please, can you hear me?
John, can you hear me? So because these app servers would need to store to share the storage, they will need a shared storage. That's why we use the SAN.
Sorry, Akosia, I think my network was bad, so that's okay.
Hello, Akosia.
Hi, Nam.
Hello.
Is John done or should I continue?
John, please, are you done?
I don't think he's done. His network is just not.
Yes, misbehaving. Yeah, John, we can't really hear you, but I'm going to try to repeat what you said. Okay. So if it is, then you put it in the chat for us, okay? Like I'm going to try to see what I understood from it. So these
so I wanted to
three.
say that I think Dennis is thinking about the whole data center maybe in a wrong sense, because it will be more
It is
beneficial
raining
to
where
think
I
about
am.
it will be more beneficial to think about the data center as like a system unit, right? So let's just imagine and picture a system unit, right? So when we go inside the system unit, then there are different parts of the whole system unit, right? So if anything will be stored on the app server itself, it will be the machine code that is running the application. Then do you understand?
Yeah, you mean the application code?
Yeah, the application code is what sits on the app server storage. And then if there's any maybe other files that the system, that's the whole application itself depends on or uses, like profile pictures, like the video files themselves, like maybe even text documents, then those documents themselves can be stored on the storage area network. And that would typically be like a collection of hard drives that are, structured in such a way that the application server has access to those hard drives. Do you understand? And then what will be on the file system database as well would be that, okay, we have different classes of users in this application. And each class of user has, this type of permission and can perform this kind of action inside this entire data center. Do you understand? And it also contains like other useful stuff, like maybe where exactly to find a file that the application server needs to run, or how to handle maybe a specific path that has like a different type of permission, or how a user with ABCD permissions is supposed to navigate through the entire system. Does that make sense?
Okay, we can move on. We can move on. Can move on.
Thank you. And so that makes a lot of sense to me. when you look at the app server, so the Nginx Apache that I'm talking about, the server, as Dennis mentioned, it does come with its own storage. So those things would be stored on the server. And when they need data that is shared, so if a user should come in and then the app server that is processing or that is doing their recording is this app server, and that app server gets so like profile information or anything about that user, the next time the user should visit again, if they are given a different app server, doesn't mean their information is gone. So that's why you need the SAN, so that the SAN is going to share that information that's that should be available to these three app servers. And that's I mean, I'm on the right track, right?
Yeah, exactly. So it's the same machine code that's replicated on the different app servers. So they are doing exactly the same thing. And then they are like their hard disk is what is their storage area network. And then they also have a file system database that manages the file paths and permissions and all those other operating system stuff.
Yeah, that's excellent. Thank you. And Yakubu.
Yeah, so I want to say something about the file system. So
Okay.
when I was reading the cloud foundations, they said AWS has Elastic Block Store and then the Elastic File System. So when I researched on the difference, they said the Elastic File System is for storing like hierarchical folders and files. So if like you have folders and files that are in a form of hierarchy in your data centers, so instead of storing these files from the data center to S3 or the Elastic Block Store, you will just lift it and put it in the AWS Elastic File System. So I'm thinking that the file system database stores folders and files that are dependents, that are like hierarchical dependents. Like it's a little complex, but that's a little that I understand from my research.
Okay. Thank you, Yakubu. Yeah, so the reason why we should understand what each of these do before we move on is because what we are going to do for the rest of this lesson is to look for the AWS equivalent. So as I mentioned, we've had our talk with the company, they have their plan and everything is in place, all the perspectives are ready for the move. Now, this is how their data center looks like traditionally. We are going to be looking at how they can get these things done inside of AWS. Okay, so I believe we can move on now and look at the AWS side of things.
Akusia, please, I would say one last thing if you permit me.
Go ahead.
Okay, so in one of the last developments I did, the application itself, after compiling everything, the application code itself was about 4 gigabytes, right? And so I'm explaining to Dennis directly. So the application code itself was about 4 gigabytes. So that 4 gigabytes of application code is what will be stored on the 3 different app servers. And then in that application code, there'll be a connection to the file system database as well as the storage area network and the primary database. So when new information comes in, the properties of that information will go to the primary database. So if the application server is looking for any information, it will go and ask the database, where is this, where is that? Or maybe what's the name of this and what's the name of that? And then that question will also be asked the file system that, okay, where can I find this? How do I get to this file? How do I get to that file? And then the file system database, okay, go to the storage area network. That is where, you can find this video file or this profile picture or whatever, which will eventually be sent back to the app server that will respond to the request of the client. And then that's the cycle.
Thank you. That's well understood.
Thank you. And so SANs are often used to improve application availability. For example, multiple data paths. So all three app servers have some data that need to be stored on the SAN because so multiple data paths, those three app servers, and they also enhance your application's performance. As a class, answer the following question based on the diagram of the corporate data center and discuss your findings with the class. So we've learned about the advantages and benefits of cloud computing. And we are looking at them with respect to this diagram that we've just seen, okay? So what are some of the benefits that we can directly relate to this data center that we've seen?
So I think I can see the server.
You can see which one?
The server.
Oh, okay. I should go back to the diagram.
No, please, can you repeat the question?
These are the advantages and benefits of cloud computing. So can you explain how these advantages are going to help when it comes to this data center that we are looking at?
Okay, advantages of cloud computing relating to this data center.
Yes.
Okay.
Okay, so I think that when this this corporate company, when they are in season or when they are in a period where they have a lot of clients, they will need to buy more servers. They need to buy more web servers. They will need to buy more app servers. They will need to buy more storage. However, if they were to have their workloads in the cloud, they wouldn't have to buy servers. They would have to just provision new EC2 instances, or when they are using managed services like RDS and Lambda, it will automatically provision new databases. And then let's say if the corporate company is out of season, then all the servers and the storage that they bought will be redundant. That means they would have spent a lot of money on the physical servers. But then if they were to have their workloads in the cloud, they wouldn't be wasting that much money. Thank you.
All right, thank you, Yakubu. So with the benefits, the first one on our list, as Yakubu rightly explained, is trading upfront costs for variable costs. So when we talk about upfront costs, your data center, you need service, okay? You go to the manufacturer or the seller and you put that upfront money. So this is how much service that we need. And then you would go and you would buy them and then you'd come and install them inside of your data center. Now you're trading that upfront cost for variable costs. When we talk about variable costs, it varies, pay as you go. Okay. So whenever your setup, you feel like you need 10 servers, then you'd pay for only 10 servers. When you feel like, or they say you pay to use only 10 servers, when you feel like you no longer need those 10 servers, you can always terminate or always destroy. So that's variable cost. You are just paying for what you use. Now, when you look at upfront cost, you've already given the money to the manufacturer, you've bought the service. Right now that you no longer have peak period, or as Yakubu put it, it's no longer your season. You no longer have peak period. What are you doing with those servers now? They have become redundant. So yeah, an advantage of the cloud is that you stop buying hardware. You'd be able to trade those upfront costs that you would pay traditionally, and now you go in for variable costs where you just pay for what you use. Gifty.
Hi, Akosia.
Hi.
I think with the advantage, another one is that when you're using the cloud, it's a managed service. So the database administrators or those who work at the data center don't have to worry so much about what goes on in the background. Looking at this setup, imagine this class, we are the data center department of a company, and we are supposed to set up this whole hardware thing with the understanding not really there. We might end up messing things up or mispositioning some of these servers and some of other things. Maybe we'll not even get to put certain things at the right places. But when you adapt the cloud method, now I just pay for the servers, and they are being managed by AWS. So you have time and then your peace of mind for other things to run in the company. Yeah.
Thank you, Gifty. Yeah, so AWS, when it comes to the cloud, AWS does a lot of the maintenance, commissioning, decommissioning. So when we talk about decommissioning, is taking apart, or what's it called? There's destroying your resources. Okay, so increase speed and agility. Deploying and decommissioning or destroying your resources would be quicker now. It would be faster because AWS does all of those things for you. So in a traditional data center, your server guys or your tech staff would now have to come in and set up and take care of wiring, connecting, all of those things. They have to come and do those things, but inside of AWS, those things are already done. And just with a few clicks, 1 minute, 2 minutes, you already have a data center, or you already have servers that are ready to run. So Gifty has helped with this. I'm sorry, Yakubu helped with this. Gifty helped with this. Ruben.
Yes, madam. So we are comparing cloud services to that of traditional. So with the traditional, I think it's a remote, or I would say you find yourself in a confined area whereby few people may get used of your products, and your product will be in this confined area. But with cloud, I think you go global in minutes, and that will scale up your production and also increase your productivity. So I think with the cloud, the advantages is more than that of the traditional way of business. So comparing the two, I think the cloud has more advantages than the traditional way.
All right, thank
Thank
you, Ruben. So we've spoken about how it's good, or it's good practice to provision your resources closer to your end users. So let's say I'm in Ghana, right? I'm in East Legon, and I have this traditional setup. If I want to provision resources, or I want to have a setup for closer to my clients in the US, number one, I would have to migrate there, like migrate my whole business there. When I migrate there, I would now need to go and buy servers. I would buy all those other infrastructure resources, and then I would build them there. Now, when it comes to the cloud, you and I, some of us don't even have passports, but we have moved from North Virginia. We have gone to Oregon. We have gone to what's it called? The Cape region. We have visited a lot of regions just from being in Ghana, okay, because AWS already has those data centers or that infrastructure in those regions already. So if I want to provision resources inside of Ireland here in Ghana, I would just be able to get stats done without even having to go there by myself. So that's it about going global in minutes, because as compared to traditional, you would actually have to go there, establish a business there, buy your servers there, all those things. But inside of AWS, we can move from what's it called? Region to region, okay, just with the click of a button. Thank you for that, Ruben. Dennis.
Yeah, so I wanted to share on a typical use case from Ghana, because I'm in Ghana. So
Okay.
that's I'll speak on stop spending money to run and maintain data centers. So you know,
Okay.
in Ghana, something like this, the way your maintenance people can steal your hardware, like steal, and I mean, every job, the prices will be inflated and all that. Now on the cloud, if you provision your services, nobody can go and remove EBS block store. And I mean, you save yourself the headache of purchasing and maintaining these huge they call it equipment. Yes, and I mean that you save money and then you also secure. So then everything is entrusted into your cloud engineer, who is going to set the right permissions for the right of the access and all. Yeah, so that's a little I also want to share.
Okay, all right. Thank you, Dennis. So yeah, sometimes when you want to perform maintenance on your traditional, I don't seem to see where the sound is coming from.
Osman.
Is Osman?
Yes.
Okay, I've muted him now. Thank you. Yeah, so the cost that goes into maintaining a data center, as Dennis said, some maintenance guys could rob you. You need to pay for security. So you need somebody to man the place. You would need to pay for cooling. You know, the servers generates a lot of heat. So you're going to have ACs inside of your data center, your wiring, your racks, those things. You'd need to be paying money to be able to maintain those data centers that you want. But inside of AWS, that is no longer your responsibility. AWS takes care of all of that, and you still get to get whatever benefits that you get or that you were looking for when you were running this. Thank you, Dennis. Odum.
Yeah, thank you, Akosia. Mine is a question. It looks like so far the focus had been on setting up a new database so that, I mean, you can easily compare and then take advantage of what AWS is offering. But my question is, in the situation where the company already have existing data center and they have trained personnel, I mean, they are working, maintaining, and again, their end users are close by and they are serving them right. How do you convince them to migrate onto AWS platform? Should they abandon their already established data center and then move to AWS or what? How will you address this?
Okay,
Thank you.
so if it depends on what that company is looking for, or why you even got into what's it called, into conversation with them in the first place. So about going global in minutes, their users are already around them, so that would not help. What you can use is trade upfront cost for variable costs. So if the country should have peak traffic, okay, if they should have high demand right now, do they have resources to be able to cater to that high demand? They have their service now, but if high traffic should come in, would they want to, how are they going to address that? So that is one point that I can think of, which is about the scaling. And aside that, can anybody think of any other? Well, there's the hybrid model too. So for backups, so they have everything on-prem or traditionally, but just so they have a backup somewhere in the cloud. So I know companies who the only thing they do in AWS is S3. So they have their traditional data center and then they collect weekly backups where they store on S3. If anything should happen to their data center right now, they know they have their information on that in that S3 buckets with their files on it. Okay, so those are the two reasons I can think of. Class, can anybody think of any more?
Yeah.
Okay, go ahead, Dennis.
So I'll just start from this point. I understand I mean what Ima's submission, that there are workers who are already used to, the traditional data center. How would they be like when the thing is it goes on the cloud? It means, well, simply some people will lose their jobs. That is if they are not, they've not also evolved to learn the ways of the cloud, to know how to manage the cloud resources. But then also,
Sorry. Let me clarify this, please. Before, it's not about the workers. It's about the stakeholders, the management. How do you convince them?
Okay. So, well, in convincing them, so I think from the cloud, the well-architected framework, we learned that you can do pilots. The move can be in a phase, like a pilot simulation. I don't like in a batch. So you can convince them using these benefits. You trade upfront cost for variable cost when there's huge peak hours, and then you need to buy more equipment. You can just, by click of buttons, expand your infrastructure to accommodate all that traffic. I mean, there are a lot of benefits you can convince them for them to know that adopting cloud is the best for their situation. And then the move,
Okay, go ahead.
yeah, and so I'll just say that the move could be in little steps. So you don't have to say, okay, today um stop running all your physical data center and then jump onto the cloud. No, but maybe some of the services could be moved in batches if it's the application that will now be hosted in, cloud application servers, and then they will still be connected to the physical storages. We'll see how that goes as time goes on. They transition to move fully into the cloud. So that's my perspective.
Right, thank you, Dennis. I believe earlier this week we're having conversation about how some tech components, some server, no, I think it was about storage, right? So we mentioned how some storage types are archaic, but AWS still maintains that if people want to use them, the option is there. So as times are evolving, yes, the company does have their data center and everything right now, but for them to get newer technologies, tech evolves fast. So for them to be able to take advantage of newer technologies, at some point they would definitely have to upgrade whatever servers or whatever resources that they have. Okay, so in that sense, they can go with the cloud, or they can then go and buy their own hardware. Okay. I think William too wants to help add something.
Yes, I want to talk about the hybrid models. Some companies put most of their resources on the cloud, but when it comes to like top sensitive documents, they like to keep it in-house on their own premises. I just wanted to add that.
All right, thank you for that. Yeah, so you can also propose a hybrid model to them where they would still be able, so since they are bent on still maintaining their traditional data center, they would keep what they want to keep here, and then they would keep others on the cloud. As I mentioned, some companies just use S3 for their backups. Every other thing is on their traditional data center. Yakubu.
Yes, okay, so what I want to add is I think that not every business will benefit from the cloud
True.
because that's why we did what was called the total cost of ownership. So as a cloud consultants, I mean, you just maybe you are being consulted, how should you move to the cloud or can you move to the cloud? So when you do your own analysis, you should be able to tell the business that, oh, I think when you move to the cloud, it's not going to help you.
Mm-hmm.
Yeah, so I think
Yeah.
not all businesses will benefit from the
Need
cloud.
to move exactly. Thank you, Yakubu. So yeah, if these few cloud benefits that we have mentioned to this company still doesn't work for them, then I think we can just let that business go. Ima, are you okay?
Yes, I think what you said in terms of technology evolving, I think that's a very good selling point because their situation now is that they already have the infrastructure. So is it that they have to sell them out or what? You get it. But I believe what you said makes sense because if the service they are having currently, with time, there will be a cake and then there will be need for replacement. So probably when that time comes, then they may have to consider migrating onto the cloud. Or maybe when those servers age and or they get faulty and something like that, then they can think of. But currently, they believe that they have everything. They even have enough capacity to handle everything. So why consider cloud now?
Okay, so just to end things, I would use Netflix as an example. So in 2008, Netflix experienced a database corruption, and for 3 days they could not ship their DVDs. So initially they used to be shipping DVDs to members, okay? So they could not ship their DVDs to their members, and then that's when they realized that they had to move away from the way their data center was set up and then move to a cloud provider. Okay, so they had everything set up in place that was working, but until this need came along, they did not what's it called, make the move. Okay, so they migrated, and in that sense they had to, I don't know whether they just packed the servers or maybe they sold them for cheap or something like that, but then they were able to move because they recognized that that move would be beneficial to their problem. Yakubu and Dennis, is there something you guys want to add?
Yes, I want to ask a question about the go global in minutes. I
Okay.
understand the explanation, but internet connection is worldwide. So if I have like an app here in Ghana, I think that someone in the US should be able to access. I don't have to set up a data center in
Yeah,
the US.
that's true. But when we are talking about go global in minutes, it's not about your users going global in minutes. It's about you having infrastructure in those countries. So a reason that we've looked at is it reduces latency. So your users are able to get a better experience when they are closer to
Oh, okay.
the web server that is serving them.
Okay, all right. So it's more about the latency and then the performance. Okay, thank you.
Yakubu, please, have you ever tried accessing a server that takes like 5 minutes or more before?
No,
Yeah,
please.
you appreciate that.
And I think
Thank you.
AWS educates too. Has anybody visited AWS educates before?
Yeah, I have.
Have you noticed
Yeah,
that
I have.
it takes longer to load?
Very slow. I mean, I started
Exactly.
that before I got my skills. And the labs I couldn't do any because it takes like forever to load, and I mean, I got bored and I stopped.
Exactly. So imagine that is your business and somebody is coming to make a purchase and it's taking that long. I'll find some other app to go and do my business on. Okay, so it's not by force, but it's just best practice to increase your users their user experience, to make them have a better user experience. Okay, because just imagine you are trying to watch a movie on Netflix and it's taking 5 minutes to buffer before you watch. I mean, you lose interest, you just leave. So it's just best practice, and it's a good idea to have something like that going for you. Dennis and Ruben.
Yeah, I had a question.
Okay.
So I want to ask that as a cloud engineer, so we are talking about maybe consulting or sometimes maybe companies approaching you and you giving them um like tidbits on why they should move to the cloud or not. So as a cloud engineer, is it your job to know, let's say if they from immerse submission, if they have like an on-prem setup, is it your job to know how to be able to connect the cloud? Let's say if they opt for a hybrid, is it your job to know how to connect the cloud to their physical infrastructure? Like, do you have to know the details of that in order to, oh, I could do that, or you just recommend that it's possible and they find the I mean the manpower to do or something like that?
Okay. So it would depend on the kind of company. So for example, if it's a startup, they've just heard about the cloud and then they now want to make that move, or they now want to deploy that hybrid model. Chances are that a solutions architect is quite expensive, and then they come to you and then they hire you as a cloud engineer. They are paying you the cloud engineer salary. What would you do in such a situation? Bear in mind that the documentation is there for you. And as a cloud engineer, though that is not really, or that is not yet your domain, but the documentation is there for you. And as a cloud engineer, you have basic understanding, like you know how a lot of the things work. Okay, so you should be able to research and then be able to know how to go around it, but you should still mention or maintain that this one is above you. But your what's it called, if it's a startup and then they need that from you, a way for you to bring value to your business would be to actually go ahead and deploy that hybrid model for them, because the documentation is there. It has everything that you need to do. Just that you read a lot, but you will be able to do it because you have the understanding.
Oh, okay. So
Yeah,
in terms of the connection, the because you are connecting physical stuff to the cloud, so
you'll do it. It's in the
definitely.
documentation.
Oh, okay. Is
Yeah,
that it?
yeah.
Yeah.
It will give you steps.
And
Dennis,
it's
don't worry.
available
When we get to the bridge, we shall cross it.
So unless it's like a company that is doing well, so companies that are doing well, usually they have should I say division of labor. So every aspect of their cloud, they have various people that are taking care of that, and then you have them in teams. People say avoid startup companies because you'll be one person and the things and the responsibilities that they will let you do. But sometimes that's like the option that you have. And if you are able to bring them that value, you are able to do that job, I feel like they would value you more. Because if you are the only cloud engineer and you've been able to set up this for them, if they are looking for people to lay off or fire or whatever, your name will never come up. Do you get that idea?
Yeah, yeah.
Yeah. So it is above you, but since you have the understanding and the documentation, if you need to do it, I believe you would be able to do it. You, Dennis, I believe you would be able to do it.
Let me ask more to Dennis this thing. I think to be an engineer, your role is to give directions as to how things should be implemented. So, and concerning the architecture, is mainly for this design and drawing. So, if you're an engineer, like, for example, a practitioner, cloud practitioner, you are the engineer. So you can give organizations the directions that they should take. But if it comes to maybe the technical aspect like drawings or design, that they should see the architecture. So in general, to be a cloud engineer, you must have, that is the reason we are reading about database, we are reading about cloud, we are reading about pattern and so. So you read a broad area for you to know the ways and the ways to go. So if the company employ you as an engineer or cloud engineer, you have the ability to direct the company, or if you take cloud services, it will help you. And this is the way, this is the direction that you should take. Then after, if they want to maybe migrate to cloud, then you may need an architecture that he will draw, or he will design the whole environment for you. So that is the little I also can share with you. Thank you.
All right, thank you, Ruben. Yeah, so in this activity, we are going to go back to that data center, and you guys are going to tell me the AWS equivalent that we can use. I think some of the services, we've seen them, some of them we haven't, but just try your best, okay? Okay. So for the service, which of the services in AWS would we use?
EC2.
Thank you. So this part is interactive, so I think anybody can unmute and give the answer, because I'm sure we'll be having similar answers anyway. So this LDAP server, can anyone take a guess?
Amazon Directory Service.
Okay, yeah. So AWS has an equivalent of Microsoft's Active Directory, and it is called the Amazon Directory Service. Thank you, John Harold. And for the load balancers.
The elastic load balancer.
The load balancers we have, there are two, but how come they've bundled them together? Because I know for the web server, they are going to have the, what do you call it? Something like the application load balancer, right? Because we
Yeah.
have types load balancers.
Yeah.
And then app servers, they are going to have, normally they use the network load balancers. Is that not it?
Both of
Or
them
does
would
it matter?
use application in this setup. Both of them would use
Application load
application.
balancers. Okay.
Yeah.
Okay. That's fine.
And so with the load balancer, I was expecting Yakubu to talk about it, because he has mentioned load balancer in this class before. Okay, so yeah, AWS has a service called Elastic Load Balancing, and you have the application load balancer, network load balancer. We'll look at those later this week. And what it essentially does is that it distributes traffic as evenly as possible. So you have two web servers, and then your people are visiting your giftyedu.com. Okay, when they come to giftyedu.com, 1,000 people have come. How do we know whether it's web server 1 that is presenting to them or is web server 2 that is presenting to them? Our load balancer would distribute the traffic for us. So that's what it does. We'll look at it into more detail as we go along. The SAN solution.
Elastic Block Store.
Okay. Thank you, Ima. So I mentioned that we can, okay, let me use Enam. So Enam mentioned that it's a bunch of hard drives inside of the SAN, okay? And we've already established in this class that when we think of our hard drives, the way our hard drives are with our machines, it's EBS, Elastic Block Store. We'll look at that too.
Can we use S3 also for that? Because we say we are storing like data.
Well, so S3, you store objects. So the kind of information that you would need from your SAN, if you can store it as an object. So if you use S3, what would be happening now is that you would have to include that logic on your app server. So now your app server, your app server is going to need to have that what's it called? The one that we use to access the URL to the individual
Yeah.
S3 files. Yeah. So I think a better option would be EBS than S3.
Okay.
And so NAS file server,
Amazon EFS.
okay.
Elastic File System.
Okay, elastic file system. So the difference between EBS
Akosia,
and
can I add a reason why S3 might not be a good idea?
okay, go ahead.
Because I think I think there's a limit to the maximum upload capacity at a time. So if you have a file that is bigger than the maximum, it means it would always fail. So then to go with EBS, you can just upload whatever you need to upload in without maybe having to break it down into parts and stuff like that.
All right, that's great. And EBS also has a what's it called? The file system, that Linux file system that we looked at. It also has it organizes your data in that order, but S3 is just objects inside of a bucket. So yeah, there are various reasons why EBS over S3 in this setup. And the NAS file server is EFS because EFS is a file system. We look at storage. So we look at the difference between block storage, file storage, and there's a third one, object storage, which is S3. So when we look at those, I believe these will be more understood. And for databases, which one would we use to store our sign-in information?
Amazon
Thank you.
RDS.
Okay.
This
RDS.
Dynamo also depending on the data, the kind
Yeah.
of data app is.
Okay. Thank you for that, Dennis.
Yeah, because are we going to treat S3 bucket again?
Yes.
I wish you go
So
over everything.
S3
In the
and
revision
EC2, those ones that you did in that first week, we will look at them again.
Oh, okay, thank you.
Yeah.
Akosia, please, I have a question.
Okay.
So my question, I mean, just for learning purpose, I'm trying to relate.
You've gone mute, oh, Dennis.
Hello.
Yes.
So my question is, I was saying that I'm trying to relate what we are doing to the physical as much as possible. So in one of our first weeks, like the initial weeks, we spoke about the issue with the national service personnel, and now I've understood the difference between the EFS, Elastic Block Store (EBS) and S3. So why did they go for S3 when they could use the EBS? Because I felt like the data on personnel and all that.
EBS works with instances, so they will need an instance to be able to use EBS.
Okay.
Yeah, so the
Okay.
data on personnel, they could be stored on Google Drive, okay, on OneDrive, because they are just files. So probably documents. So that's when they went for S3. And S3 is cheaper than EBS.
Okay.
And I think EBS too is cheaper than, no. Okay, so for EBS, you pay for what you provision, and then EFS, you pay for what you use. S3, so you pay for what you use. So S3, in this sense, S3 will be cheaper because EBS, they would now need an instance and attach that hard disk to the instance. And I don't think they have any, they don't have any, what's it called? Function. So the way you go to Jennifer's app to go and do a recording, or you go to somebody's app to go and do calculation or something, NSS didn't have any need like that. They just wanted somewhere to store their backup files or to store their files. So in a case like that, Google Drive works, and then S32 works.
All right, okay. Thank you.
You're welcome. And And I think another thing I should bring up too is that is why inside of S3 you can host a static website, but when you want to do to host a dynamic website, you'd have to use EC2 and have EBS attached, because then server-side processing can happen because you have the instance. But S3 you don't have access to the instance, so it's just a static website just showing those objects or those pictures that you are displaying. Then is that clear?
Yes, please, that's clear.
Okay. Yakubu.
Yeah, so I want to know the AWS Active Directory. Is it doing the same thing as AWS IAM?
No, please. They do two different things. So the Active Directory is the way you, so inside of IAM, one of the options that you can use for IAM, instead of you creating your user attached policies, those things, what you can do is to import the Active Directory that you were using on your company. So inside of your company, you guys were using this this one. When you move to the cloud and you want to create users and those things, AWS gives you the option to create users and all of those things, but you can also import the information from the Active Directory. So you can integrate the Amazon Active Directory with IAM, so that you don't now have to go and fill in all of those the names of those users. So if a user or an employee from your company is trying to access any resource over inside of your AWS account, it's the Active Directory service that would authenticate and authorize them, because you've integrated it with IAM. So I don't know, they work hand in hand. Like you have the option to make them work hand in hand. Yakubu, is that okay?
Then we've integrated the AWS Directory Service to IAM.
Yes.
Okay.
And you also have the option to use your IAM as raw as it is, and then still have your AWS Active Directory Service. You have those options available to you depending on how you want to go about it.
Okay, all right. And then I realized that like we didn't talk about the NAS storage, the network attached storage.
Okay. The one, so we likened that to what's it called?
The EFS.
Yes, we likened that to EFS.
No, I thought the EFS was the files database.
No, EFS is not a database, or it's a storage option just like EBS, but EBS is a block store and EFS is with file system. So EBS is one-to-one. So each EBS volume has one instance. And if you want them to share, a single storage, then you would go for EFS.
But I saw some file database somewhere.
Yeah, there was also file database over there.
Yeah, that's one of my questions. The file system database is missing in this diagram. We didn't have any matching service for it. Or
Well, so the
or
file,
the EFS would do everything.
then I guess the EFS would do everything for both file system database and network storage. Yeah, I think EFS can do both.
Okay, please can I give an explanation of the network attached storage again? How different is it from the other storage?
You mean the SAN and the NAS, right?
Yes.
So
But the SAN I understand, but the NAS I don't understand.
So the NAS is just like EBS, EFS. The NAS would help them to be able, help these three instances to be able to share one storage. So it's for file sharing.
Okay.
And it also has the hierarchical file system, which the EBS, I think EBS has. The EFS has the hierarchical file system. So these three would be able to share a single storage with the use of the NAS. Dennis and so we're actually done. Dennis and Chima.
Sorry, my second question, please. You talk about the EBS, that the EBS you said you pay for it or something like that. Yeah. So I want to get clarification. I know the EBS, if you provision your instance, then you attach an EBS. So once you stop your instance, the AWS will still continue to charge you for the EBS, right? But so long as it's attached and it's being used, you don't get charged for the EBS. Is that correct?
Yeah, that's correct. You pay for what you provision. So if you guys remember when we were doing the SSH, a lot of you provision 30 gig of EBS, though the files or the things that you have on that EBS is not reaching 30 gig. You guys are paying for all the 30 gig. So I asked that you reduce it to 8. I think that's the least. Yeah, so with EBS, you pay for what you provision. In EFS, you have the option. You have the option to pay for what you provision or to pay for what you use. S3, you pay for what? I'm asking you guys.
What you use.
Exactly. So this one, what you use, this one, what you provision, and then this one, you have the option to choose between whether to pay for what you use or to pay for what you provision. But by default, it's you paying for what you use in EFS.
No, Akosia, please. So I want to get this clarity. So if I provision an instance and the EC2 instance is running, do I pay? Because the EC2 instance, depending on whether it fall under free tier or not, you pay for it as well. So my question is, in that when it's running, do you pay for both the EBS and the instance?
Yes.
Oh, really?
Yeah,
I thought
and
once it's running, you don't pay for the EBS. You only pay for it when it's not running, just like the Elastic IP. Or
you pay for the EBS and you also pay for the instance. So EBS is not the only storage option that you can use with your instance. You can use EFS, you can use instance store. So with instance store, that one is physically attached to the instance. With instance store, you don't pay. So you don't pay for the instance store. So your cost of the instance would like automatically, yes, take care of that. So with instance store, yeah, so the thing about instance store is that it doesn't persist. So if you should stop your instance or a crash or something, everything you have on it is gone. You don't pay for instance store. But if you don't want to attach instance store and you want to attach EBS, which persists, you would have to pay for that provisioned EBS. So your instance could be stopped, but the hard disk is still attached to it. They can't assign that hard disk to another client. Do you understand?
yes,
so
that's
you
correct.
still pay.
Yes.
So you still pay for it because it's still attached, though the instance is stopped.
No, my confusion was on when the instance is running, you still pay for the EBS, right?
Yes.
Okay. Thank you.
You're welcome. Dennis.
Yeah, so please, my question was on the EBS attached to the 3 instances. So does it mean that, let's say, when we launch an instance or provision an instance, we can attach one EBS to 3 instances?
No, we can't. EBS is
Like,
one-to-one.
okay, so from the architecture, we have one EBS attached to the 3 instances.
It's demonstration purposes.
Okay, so if it's one-to-one, then how is the so because it's going to store data that the application needs, right? Which is being served on the instance, and the application must have the same data. I
It
don't
will
know,
be
like
here. It will be stored here.
on the EFS.
Yes, so that they can share.
Okay, so okay, I guess now the EBS in this case stores the code of the app, not the.
Yes.
Okay, Okay, thank you.
You're welcome.
Akosia, please. I think Dennis is trying to match this to the on-prem one that, or the traditional one that we looked at earlier. That's the EBS is representing, I think, the sun, and we know the sun is shared storage. So how come that when we migrate to AWS, this EBS, which is representing sun, is no longer a shared storage? I think that's his question.
Exactly. Yeah. Mr. Nabro, phone MBE.
I actually understood, but EBS is one-to-one. There's also EBS multi-attach, and that's SA level. So you guys just understand that EBS is one-to-one.
For me, my confusion is with the traditional setup because I've never experienced a traditional data center before.
You and me both.
Yeah, so I also understand it this way that this traditional is their way. Is a corporate that they have designed their way of storing and so provision for their own environment or cloud environment or on-premise environment. So the understanding is to migrate from this traditional way to cloud. How is it going to be positioned? How is it the system is going to be positioned? And the cloud architecture here has revealed to us that this is how it should be provisioned. That's the NAS and the SAN. The SAN belongs to the EBS, and the NAS and the file system also belongs to the, what is it? Can you please give me the architecture drawing?
The EFS.
Yeah, yes. So this is how I want to take it, because that is corporate. Although it's good to know, maybe you may be going to a certain corporate institution and you must know this, maybe they have the same similar system, you must know. But coming to the cloud is how the cloud also takes it.
Okay.
So this is how I also I grab it.
Okay.
Otherwise, speaking about it, and you may not know, unless
Yeah,
maybe
so
we get
there
the
is
technical.
EBS multi-attach. Okay, you can attach an EBS volume to multiple instances, but I feel like it's beyond this class. But since it is in your what's it called, in your slides, then I think we should just go with that. So these instances would be able to share that and they'll be able to share because you can replace SAN solutions with EBS volumes. They didn't say volumes, because ideally EBS is one-to-one. But if you're able to follow those restrictions, so the restrictions are they should be in the same AZ, they should be of the same server type, those things. If you're able to follow those restrictions and provision a multi-attach EBS, it would still work. If your use case needs to get their way out of that provision, because you can't have both in the you might not have the chance to have both of them in the same AZ and all of those things. So then you go for EFS, but there's an EBS multi-attach option.
Okay, so
Akosia, sorry. Can I please say something? So what I'm saying is that if you really want to go by the SAN, then you may think of even using the EFS, since that one can be shared. Until just now you made mention of is it a multi-EBS or something like that?
Yeah.
Okay. So what I am seeing is that it's about the purpose, not necessarily matching onto this, because when you consider the purpose of the SAN, clearly EBS can, function or perform the same purpose. Probably that's why they are using it for that.
Okay.
That's the way I am seeing it.
Yeah, that makes sense.
From the way Enam explained, the SAN, I think EBS serves the same purpose.
Okay.
Thank you.
Thank you, Emma. Dennis.
Yeah, so my mind was just drawn to this when I read the definition under the EBS says the last part says you can attach these volumes to application servers to store long-term data and share the data between instances. And I just remembered that I've not seen VPC in the setup. And we said VPC is the cloud data center, but I've not seen any reference to VPC in both the cloud and the distro. So please, I don't know if you can clarify.
Okay, so in this setup, where the VPC would be,
I think these are the resources
it can
that
cover
will be
everything.
within the VPC. Well, the VPC is the data center.
Because
Yes,
I'm
we
trying
do the
to,
data
I'm,
center.
I'm, I'm trying to see if, what's it called? If there are some resources that don't need to be provisioned within a VPC, but I see none. So, okay, this one would be out of your VPC, this directory service. So in a drawing like that, this AWS cloud, guys, let's try to
What about S3?
imagine what
S3
I'm talking
doesn't,
about. S3
S3
too
doesn't necessarily
would be
have to be there.
outside.
Yeah.
So what's it called? This box, this AWS cloud box, it will end maybe somewhere here. Let me check if EFS is VPC bound. Okay, so EFS2 is VPC bound, although you need additional configuration. So the box would look something like this. Do we get it? So this ST and then this Active Directory Service are out. They don't need to be within your VPC. I don't know if people are understanding what I mean. Which example card do I have?
Hello, Akusia.
Hi.
I think I want to help clarify the EBS shared storage situation.
Okay, yeah. So go ahead while I look for what I'm looking for.
So what happens, or from the little reading I've done, is that if we refer to the initial diagram, that the on-premise diagram that we're looking at, right? Since EBS is one-to-one with the instances, you can have multiple instances, right? And those multiple instances will be running the same code, right? And then there's so each of the instances come with their own file systems, right? And then they're all connected with a load balancer, and they all have access to a database. So what happens is that the database serves as kind of like a map to where everything is stored in the system. So even though you might not, for example, I'm a user and I make a request to the first instance with, let's call one EBS, EBS A, which is attached to instance A. And then there's another instance called EBS B, which is attached to instance B, right? When I make a request and the file is stored on EBS B, but then the load balancer directs me to EBS A, what will happen is that even though you can't find the file the database would obviously show you that you can't find the file in EBS A. So to redirect, the load balancer will redirect you to EBS B, right? Where you can definitely find what you're looking for, and then the request will then be responded to. But then all this will happen in less than half a second. So it might seem like it takes a long time, or it might seem like it will delay, but it won't actually delay. It will just be like that quick.
Okay.
Does
Thank
that
you.
make
And
sense? Because
yeah.
from the reading I did, there's a way to share so I think we've even done it before. You can connect two different instances, right? And the idea is that once you can connect two different instances, then
logically speaking and practically speaking, those two instances can also share resources and files.
Yeah.
Do you understand?
So for you to connect to different instances, that means that maybe you want them to share application code, which ideally should not be, okay? So everything this instance needs to thrive or needs to function should be stored on it. Everything that this one needs should be stored on it. The thing about file share storage is that if today Yakubu comes to register on this website, okay, and the ELB directed him to this instance, and then the application server that did his registration request is this instance. If another day Yakubu should come and he's directed to a different instance, it shouldn't be that his information is lost. And so we won't be able to give him that information back. Okay. That is why we need a file. Let me use this. That is why we need a shared storage. As this instance is taking Yakubu's information, it's storing it here. As this one is taking it, it's storing it here. Okay. So the application code and everything that the instance needs to perform its job, okay, all those things are going to be on the instance. It can individually do all those things, but when it comes to information that another instance might need another day, then those ones should be stored on the EFS. Or yes, so that's why you need an EFS, because there will be some information that if Yakubu should come and meets this instance another day, his information is not lost. His information is there for him. Is that okay?
Yeah.
Okay.
Yeah, it's okay.
Yeah, so Dennis, with the question about VPC, what's the VPC? So this purple line that we are seeing, this I don't know why this is blurred, but I hope we can see. So with this purple line, that's the VPC. So inside the VPC, your load balancer, your instance, your IDS, all those things are within your VPC. Something like IAM or Active Directory or S3 can be outside of your VPC because those ones are not VPC bound. So let's go back to our example. If we had to bring a VPC around it, it would, as I mentioned, it would be here because these resources are within the VPC. And what the VPC does for you is this ELB, this instance, this all these things, for them to be able to use your network, yes, your private network in AWS, they all need IP addresses. Okay, they all need internal, is it internal? Private, they all need private IP addresses, and the IP address that each resource gets is dependent on the VPC that it is in. Okay, so this week for the first time I saw an account with no VPC. Ruben had deleted his default VPC from there, so I created an instance. And you know, when you're creating the instance and it gets to the network side, you need to specify what VPC that the instance is going to be in. I could not create my instance. You need a VPC so that the resources that you provision in AWS, they all have the private IP address. Okay, so that if any configurations or any connections are being done, they will be able to identify them. That this is on my network, this is on my network, and it can access my network resources. Please, is that okay?
Yeah, that's fine.
Okay.
So, where would, let's say, the route table fit in this context?
Okay. So the route table would sit still inside your VPC if you have multiple subnets. So let's say one is a subnet and then one here too is a subnet. Then you would want to what's it called? Associate those route tables with their subnets. But in this case, is one. So let's say one big VPC, one big subnet. All of them are together. So a simple route table over here saying how everything should be routed would do. So a box here where the mouse is representing the route table. That's it. But
Okay.
within the VPC.
Okay. All right.
You're welcome. Okay, I'll see you guys in the afternoon.
Yes, please.
All right. Have a nice day.
You too.
Hello, madam.
Hello.
Someone was saying he hasn't received the data.
He has received or he hasn't received?
Which one? We cannot hear you.
He hasn't received the data.